Hello students, in our last lecture we discussed about 6 simple machines which were inclined plane, screw, wedge, lever, pulley and axle and wheel. Now today we are going to study about few technical terms of which are often used in these 6 simple machines. These technical terms are basically this is what the formulas of finding out how effective the machine is, how effective our work is being done, all that respect. Okay, so first one is for all the 6 simple machines, the important point which we are going to study is called mechanical advantage. So what does mechanical advantage means? See, as this name suggests, mechanical advantage is basically comparison of load and effort. That means output force upon input force. So what we are discussing here is we are relating the output force which has been performed by the machine and the input force which has been applied on the machine. So we are comparing both and we are finding the mechanical advantage. So the formula for mechanical advantage is very simple. It's output force divided by input force. Now in your books you might see this in more simpler form, which is called load upon effort. So basically what load is the output force required. Suppose with a lever, this is my fulcrum, with a lever I want to pull or push some particular weight. Okay, so that weight will be called load, whereas the force which I am applying on the other side of the lever will be my effort. So this is load over effort. So this is the simple formula. Now another term which you will be asked for is called velocity ratio. So velocity ratio is, it's actually not the ratio of velocity, well it is, but indirectly actually it is the ratio of distance moved by load and effort. So this is ratio of distance moved by, you have to remember that in mechanical advantage load is in the numerator side, whereas in velocity ratio effort is on the numerator side. So distance moved by effort over distance moved by load. So these are two formulas which we'll be using for all of these simple machines. Let's start. First of all, we are talking about inclined planes. So you can see that Egyptians also used inclined plane for the construction of their very famous shape called pyramids. So that is just an outline. This is the shape of, this is a real picture of a pyramid. Now I'll explain it. The Egyptians used simple machines to build the pyramids. One method was to build a very long incline out of dirt that rose upward to the top of the pyramid very gently. The blocks of stone were placed on large logs. Another type of simple machine, the wheel and axle, and push slowly up the long gentle inclined plane to the top of the pyramid. So basically what this paragraph explains is the construction of pyramid, how it was made. So they used the method of simple machines only. The one method was to use very long inclined plane. So they used long inclined planes like this, and then they used to carry heavy load with the help of wooden logs. So what is wooden log doing here? Wooden logs are like, I'll place 2 or 3 markers like this. Okay, so this marker are my wooden logs right now, and whatever load has to be taken, it will be slided over the logs. So it was very easy to carry load up to the top. So this slope of the whole thing was very gentle. Okay, so this slope was made out of the dirt. So they used to push heavy stones through this inclined plane using wheel and axle system, and that is how they made the huge pyramids. So see, they use very simple machines technique. Now inclined plane is a flat surface. This is the same definition which we done in our last class. Inclined plane is a flat surface that is higher on one end. Okay, inclined planes make the work of moving things easier. Now work input and output. First of all, for inclined plane, work input is the amount of work done on the inclined plane, that is on a machine. So input work done is what? Work is force times displacement. So for work is input force times input distance, whereas work output will be obviously same as force into displacement. It would be output force into output distance. So see this example here. this length is 15 meters and this length is 3 meter. Okay, so what is work output is equal to work input. If it is seen that equal amount of work has been done, so see in the work output we have work output into distance output, whereas force input into distance input, both side force. Here force is 10 into 3, why 10 newtons? This is a mass of 1 kg, so the weight becomes 10 newtons. So if this thing has to be raised this much, so what would be the formula? 10 times 3, that will be work done, and in here it will be what? 2 times 15, because the slope is, this height is 15, the length of the slope. So the same amount of work can be performed either by taking a 2 kg block or 10 kg up to 3 meters. So this is how inclined planes work. So mechanical advantage of an inclined plane, now comes our formula of mechanical advantage, is equal to length of the slope divided by height of the inclined plane. So we are finding mechanical advantage by length upon height of the inclined plane. So for example, in a last diagram we had this 3 and 15. So according to this formula, we have length of the inclined plane divided by height of the inclined plane. So this comes out to be 15 over 3, that is 5. So 5 is the mechanical advantage of this shown inclined plane. Okay, now with the inclined plane, see this point is necessary. While the inclined plane produces a mechanical advantage, it does so by increasing the distance through which the force must move. Through which the force, this is not force, this is actually the other body, force on the other body which the other body is moving. So that is what mechanical advantage is all about. Alright, now we'll move on to screw. We have seen that screw is basically a inclined plane only, but it is wrapped about a conical section or cylindrical part. Alright, the screw is an inclined plane wound around a central cylinder. So we have done this basics yesterday. Wedges, 2 inclined plane joints back to back, we have done this as well. So we are going to study mechanical advantage of wedge. So what is mechanical advantage of wedge? Of a wedge can be found by dividing length of either slopes. Basically there are 2 slopes in a wedge. Okay, so length of either slopes divided by thickness of the big end. So suppose these 2 are the slopes, so length of both the slopes, that is 2 times s divided by t, that is thickness of the higher end. Next, levers. See, levers are of different classes. There is first, second and third class. We are going to discuss all of them one by one. First we are going to start with the first class lever. First class lever is the simplest form of lever where the fulcrum is in the center and the load and effort are in the different directions. For example, you can see this picture. So fulcrum is between effort and load. Okay, now if load is heavier, then fulcrum moves towards the load, because the distance multiplied with the effort becomes large and hence effort becomes small. So what we are talking about here is moment. Moment is basically force into perpendicular distance, and moment of force is always equal. That's what makes things work. So here, if I want to decrease the value of effort that which I am applying on an inclined plane, or basically this is a first class lever, then I should move for this fulcrum towards load so that my length of the effort arm increases. So what are the technical terms here? Effort, load, fulcrum, this is load arm and that is effort arm. So according to law of moments, load into load arm will be equal to effort into effort arm. Now here the mechanical advantage of his lever is the ratio of length of the lever on the applied force side to the length of the other side, basically on the load side. Next is our, see, these are the examples of common first class levers. The things which cobblers use or which mechanics use, they use the first class lever. Then the seesaw, then pliers. These are all examples of first class levers. Second class lever is that where fulcrum is at one of the end while effort and load are both on the other end. Okay, so they both lie on the other side of the fulcrum. See, now effort move farther than resistance when the load is between fulcrum and effort arm. So this is your key point to remember, which if it is a second class lever or not, where the load will be between fulcrum and the effort. Alright, so mechanical advantage of a lever is the ratio of same, the distance from the applied force, that is effort into effort arm, and the load into load arm. Second class lever, the nut breakers, these are second class levers. Then axle, the towing machine which is generally used to pick up garbage and all, that is also a second class lever. Then we are moving to third class lever. In this case, both effort, like in the second case, both effort and load are on the same side of opposite to fulcrum, but the difference is this time effort lies between fulcrum and load, whereas in second class lever, load lies between fulcrum and effort. So here also the mechanical advantage is the ratio of distance from the applied force to the fulcrum to the distance of resistive force from the fulcrum. Same thing, load into load arm and effort into effort arm. These are the examples of third class lever. Our biceps from elbow point, if we are picking anything up, this is, here we have fulcrum and load is this, effort is applied in between. Then shovels, this is also a third class lever. Pulleys, we have discussed the basics of pulleys, which are circular disc free to move in their particular rotational axis, and then it is usually used with a rope. Then rope is the factor which decides whether how much effort will move, how much load will be applied and all that. Okay, so this is the pulley diagram. Here this load is being pulled upwards by applying a force on this side vertically downwards. This is a moving pulley where effort was applied on this side, so load as well as pulley moved. So that thing is a fixed pulley and the other one is a movable pulley. A fixed pulley changes the direction of force, because see, if I have to lift this box up, I had to apply force in vertically upward direction, but with the use of pulley, now I am my force of direction is downwards. Actually, sorry, direction of force is vertically downwards. So it completely changed the direction of force. Whereas in this case, the direction of force, applied force remains same, but our task become much easier. Okay. So